Given that z is equal to a plus bi is a complex number where a and b are real constants, show that z multiplied by its conjugate is a real number. So all we're doing here is a plus bi multiplied by a minus bi. And that's going to be a squared plus abi minus abi minus bi squared. And of course we didn't need to do all of that because we can see that this is a difference of two squares. And so we knew that those middle terms were going to cancel out. And I squared is -1, so it's just a squared plus b squared. And since that a and b are real, that implies that a squared plus b squared is real. So that's part A done. Now we're given some extra stuff. We're told that z bar is equal to 18. And we're given z divided by z star is equal to this. Determine the possible complex numbers z. Now, since this is z star, which was something we worked on in the first part of the question, it seems tempting just to use the a squared plus b squared there. But I must admit, I didn't do that. I started this by calling this 1 and calling this 2 because we have simultaneous equations. And then for 1, that tells me that z star, the conjugate, is equal to 18 divided by z. And then I substituted that into the second one. So I had z divided by 18 over z is equal to 7 over 9 plus 4 root 2 over 9i. And dividing by a fraction, we've got z divided by 18 over z, so it ends up being times z over 18. And so what we have is that z squared over 18 is 7 over 9 plus 4 root 2 on 9i. Multiplying both sides by 18 gives me z squared is equal to 14 plus 8 root 2 I. And then I'm going to let z be equal to a plus bi. That means that z squared is, so we're multiplying a plus bi, that's going to give me a squared plus abi plus abi plus b squared I squared. So that gives me a squared minus b squared plus 2abi. And therefore, a squared minus b squared is equal to 14, and ab is equal to 4 root 2. Just comparing this with this. So let's call these 3 and 4. And then number 4 gives me that b is equal to 4 root 2 divided by a. Sub in 3, and we get a squared. Take away 4 root 2 on a squared is equal to 14. So 4 root 2 squared is 16 times 2, 32. So that's 32 over a squared equals 14. And we can multiply through by a squared and rearrange this to get a to the 4 minus 14a squared. Take away 32 is equal to 0. So that's a squared minus 16, a squared plus 2 is equal to 0. giving us a squared is 16, or a squared is equal to negative 2. Now remember, when we do this, a is always real, so that one can't be true. So, continuing, we have that a is equal to positive or negative 4. If a is equal to 4, substitute back to just here. And if a is equal to 4, b is going to be root 2. And if a is equal to negative 4, b is going to be negative root 2. And so we have 4 plus root 2i and 4 minus root 2i.